All right, so these just get to watch. So example 1 here, we're finding the derivative of this where the product rule is the most outside function. So then, or the most outside operation. So first d second plus second d first. This one, the quotient rule is most outside, so you start with that, low d high. And to take the derivative of the d high, you've got chain rule going on. So take the derivative of tangent secant squared, carry the x cubed, multiply by the derivative of the x cubed, which is 3x squared, minus high d low, derivative of x cubed, that's straightforward, derivative of e to the x squared is chain rule, e to the x squared times 2x. Square the bottom and off you go. All right, so this next one here, I have 3 layers. F and G and H. So you start by taking the derivative of the most outside function. So that's secant squared, and you carry the inside along. So the next inside function is the cosine. So I take the derivative of cosine, get negative sign, carry the angle along. Take the derivative of the angle, and as I'm taking the derivative of that, I'm not carrying anything along, so that's how I know I'm done. All right, let's take this derivative. So I start with the most outside, which is the 3. And again, I'm going to get in the habit of putting the 2 there, writing the inside function. Now I'm going to take the derivative of the cotangent, which is negative cosecant squared. And I carry the e to the x along. Now I'm going to multiply by the derivative of the e to the x, which is e to the x. This one here, I'm going to invest the time to rewrite it first. All right, so now I'm going to take the derivative. So I'm going to bring the 1/2 down to the negative 1/2. Okay, looking for the next inside function, which would be secant. So I know the derivative of secant is secant tangent. So again, I like to write down the trig function and then take the time to write the angle in on both of them. Now I'm going to take the derivative of the cotangent, which is negative cosecant squared. All right, so let's do some more, just product rule with the rules that we know. So to take the derivative, I'm going to use the product rule. So I have first d second, so the derivative here would be e to the cotangent. There's a derivative of cotangent, negative cosecant squared, plus e to the cotangent times the derivative of cosine, which is negative sine. So I'm making sure that you know that if you see this written here, it really does mean just cosine of x and then times this, right? Or it could be rewritten. So there will be parentheses around the angle if it means to include all of it. All right, first, this is a crucial thing. Rewrite this as x to the negative 1. So this is the same thing as saying x e to the x to the negative 1. This one a lot of people make mistakes on. So let's be careful on this one. So first, d second. So the derivative of x to the negative 1 is negative x to the negative 2. Plus second d first, which is just 1. So if I was to rewrite this, which it's going to be necessary as we move on, plus e to the 1 over x. So here's an x canceling, so I get a negative e to the 1 over x plus e to the 1 over x. All right. Here I see the product rule up in the exponent. So to take the derivative of e to the stuff, it's e to the stuff times, and since I know I'm going to have product rule, I'm going to put parentheses. So first, d second plus second d first. All right, let's do another one here. So I see this is up in the exponent. This is the same thing as saying tangent cubed. So derivative will be e to the stuff times the derivative So bringing the 3 down, carrying the inside along, squared power, and multiply by the derivative of the inside. All right, so again, I'm just kind of reminding you of this rule. Let's just go through a couple more here, finish this page. So I see quotient rule happening. So to take the derivative, so it's low, d high, 3 to the x, ln of 3. It's always ln of the number, minus high, d low, square the bottom, and off you go. All right, so this one here, I see product rule again. So first, d second. So the derivative of secant is secant tangent. Carry the angle along, then multiply by the derivative of the angle, plus secant of x squared times the derivative of a to the stuff is a to the stuff times the derivative of stuff times ln of a, ln of the number.